Hi my friends, let's model the part 100 superior housing, the last one in my collection of parts. The picture shows us no too many details, but if we take a look at the drawing, we see that are a lot. Yes, this is the part 100. The last one. You see, we have tolerances, but there are many hollows inside with various shapes. Here is a curved wall. Yes, you can see it here or here. This is curved, but we don't afraid. We have the power to model anything. Yes, we start by creating this disk, yes, with the definition here, diameter 150 and so on. You have all the detail in the drawing. We also have a tolerance here. Let's create this first volume. The plane is XY, and we draw some lines. The profile of that disk. First dimension is 150, as you saw, and this is a good scaling. This dimension has tolerances. I leave dimension tool and I select dimension properties, where we have possibilities to select a name for every dimension, precision and tolerance. As you saw, A, lower A, 11 is the tolerance. We have all of them here. A, small a. Oh, but I have to go here because this is a shaft, not not a hole. Yes, we dimension here a shaft. This is a shaft. You see the values, they are precisely effect of this A11. Okay. Trailing zero are not here, but in the drawing IDW you can place as many trailing zeros or other things at your will. Other dimensions are 147, all, no, this is 5, and all the thickness is 20. Finish sketch, F6, revolve. This is the first volume. The next one is this one, yes, this one, external dimensions. We see here diameter of 80, diameter of 160, 82 with tolerance between the center point, which is in the middle of this end of this line on this face. So we have to place somewhere this 102 with tolerance is on vertical, and we'll take a look at the drawing anytime when we don't remember something. This is the plane, F7, and we draw a line for the start, a vertical line. I want to place it in position to have a reference. 102 is this, with tolerance plus minus 0.1. So I escape from dimensioning, right click, dimension properties, symmetric, 0.1. Okay, you see the dimension. And 82 plus minus 0.1 between the end of the line and the center point. 82, escape, right click, dimension properties, symmetric, 0.1. These tolerances can be added easily in the drawing after we finish the model, of course. This is a center line, and we continue with the other lines, which are no many. That's all. Yes, there is a fillet radius 4 between these two lines, and diameters 80, as you remember, no tolerance, 160, and 30 degrees, 30, but also another dimension of 11 here. Now is completely defined. Revolve, OK, F6. Next is an extruding volume, this one, this one, and this one, with the definition here, you see 50 from the axis of the revolving volume, and here ends on the bottom line. But we have to be careful to apply this 8 millimeters at the end. Let's create XY plane, F7, line from this end, midpoint to its correspondent. We draw now a line, as you can see. I hope is horizontal, I'm not sure, and we go back with a vertical ending here and back to the midpoint. This is not horizontal. 5 millimeters here. 50 is this line. 8 to the right, and an angle of 30 degrees. Finish sketch. The extrusion is 53 symmetric. Extrude 53 symmetric. Okay. As you can see, this is 55, this is 53. The difference between them is this this gap, which is 8.5 millimeters. Yes, let's do it. So XY plane, F7, line, start from the midpoint, then we draw some lines. Perpendicular, and this one also perpendicular. Eight point five. Collinear, but I have to project this geometry, and that's all. Good. Finish sketch. Extrude. Symmetrical. 55. Okay. As you can see, there is a gap here down. Good. Now we must apply this ears with dimensions here. 120 is the angle here. Radius 14 on a circle, but this is inside, not important. Okay, 13, 14.5, and we create this in a plane up from the bottom with the difference between these two. We start with that plane from here up minus 14.5 plus 13. This is the plane where we create a sketch. X to the right. F7. We draw some lines, one vertical, an arc like this, and another line. I project this circle, but I want to be construction to have this point. Why? Because the distance between these 2 points is 175 divided by 2. The angles are 45 is this, and 30, not 30, but 120 divided by 2. 120 divided by 2. And this is 120 divided by 2. Okay. Radius 14. And now white lines. This is a construction line, and I place on the same horizontal this point with this end. Why? To create an arc with the center in the center of the circle, starting from here, ending to the other line. Trim. And now we have the definition of the ear. Finish sketch. Extrude on 13, the other direction. Okay, this plane is no more interesting. A hole, you see, 14 is also the hole. Okay. Hole, simple, through this face, this center, and diameter of 14. Okay, and now we mirror both hole and extrusion about XY plane, which means this, and then we also mirror, but we need a plane, so we create a plane in a known manner. Start plane, select this face, Now I want to create a point, but I need an axis of this intersected with this plane, and now we have the plane parallel with this and containing this point. Mirror about this plane. Okay, all of them are present. Visibility F6. We continue with this. This is a contour with a definition on a radius of 87. There are two holes with a tolerated dimension, radius 13. We have to eliminate this to remain that contour. Remarkable is that these two lines are existent lines. They are these faces, yes, these faces, and we can make a sum. Twice 13 plus 27 means 53, yes, and 53 is this. Then we have to eliminate here only from this point to here, here and back, yes. This is what we have to cut by using extrude. Let's do this. Remember, this is with tolerance. We turn back the part and we create a sketch drawing a line to be axis, and then two radius, 1 and 2, which are symmetrical above that axis and equal. The length is 87 aligned. The length is 87 aligned. And the distance between ends is 27. Now we create an arc starting from here to the line, making it tangent with the line, and applying mirror about this axis. Apply. Then we draw a line here, which also must be tangent. Okay, now what we have to eliminate this area. Yes, I don't place a dimension of 13 because it is not necessary. It is resultant. Finish sketch, extrude this 2 with cut to that tiny face to here. Okay, that's all. Yes, you see the result. F6. Next is a hollow, this one, which or this one, which has a contour like this, because now all is filled here, filled with material. I created a sketch for you to see what is the contour. Yes, radius 10, and dimensions are 45 minus 7 minus 7. Yes, placed to the center here. Yes, all of this will be hollow. The dimension on horizontal extrusion is 55 minus 7 minus twice 6. Yes, let's create. The plane for the sketch is based on XY and at a distance of 7 divided by 2. Sketch F7, and we draw that rectangle from here to about here, and we project the superior horizontal to apply coincidence between this line and this midpoint. The other dimensions: 7 from the bottom, 7 from the right, and as I said, 45 minus 7 multiplied by 2. The radius 10 is a circle with radius 10 placed at the distances in the drawing. 4.5 here and 8 from the right. 8. We have to draw a small line horizontal here, tangent, and trim. Trim this and this arc. Okay, and also trim this end together with the other. Finish sketch, extrude, as I said, 55 minus 6 multiplied by 2 minus 7 and all divided by 2. By 2 and cut. Okay, this plane is no more useful, and now let me show you what is inside. Half section view from up to that. Yes, this volume extracted from the part, or from this plane. You see that hollow is visible. Good. Now we have to multiply to mirror this hollow on the other side of the plane. Mirror. Last feature about the plane XY. Okay, nothing is visible. Another way to see inside the part is wireframe, of course, and you can see that two hollow cubicles. We go back to our presentation, but with this present. Yes, I selected the other presentation with the hidden lines presented. Okay, next is to create these two holes of 15 placed on the circle of 115 and at a distance of 25. Let's create. This is the face, the circle 115, but diameter, a line of 25, two points at the end, the same vertical, I suppose, of this point, yes, vertical, and one of the points to be on the circle. Yes, this point coincident with this. Finish sketch. Holes 15. 15 is selected. To what? To this very face. Yes, this. Okay, now we can see inside that cubicles. Good, F6. Now we have to create this round wall which I mentioned at the beginning, with this L shape, but I created it is presented in real dimension here. Yes, this section is a proper diametral section. This is not. Yes, this is with steps. I created a better presentation of this here. This is what is to be revolved. This is the real dimension, real presentation, and we have to limit this to the hollows created already. Dimensions are 146 for this end, 8 millimeters here, and this is over the circle which is dimensioned here, 132. Yes, this is where the L is finished. On vertical is the room which limits that contour. Let's create it. The plane is XY, F6, F7. And now I draw outside the contour, which is an L. The only dimension I can apply here is this 8. Home. You see, this is the center of homotety, and all is extended to here. And I have another dimension, a real one, to be placed, which is this, also 8. I project lines from the room inside, which are this, this, and this. I make this center line, and now I make collinear these two and these two lines. Diameters are 132 for this and 146 for this, as you saw in the drawing. Finished sketch. This is the contour, and now we have to create a revolution. I'll use sweep, so I have to create this arc. Yes, this will be a join volume, not cut volume. Yes, to create a wall. Good. The plane where I draw that arc is the bottom of the room. This one. Sketch. F7. I want to project also this. Project. Let me select another view. This. I project also this line as a point in my sketch, and this line as another point at 132 from this. Yes, you remember. And now I draw an arc. Center is here in the projected point, and I start from this end to this end. Here is over, so trim. They are in the same plane, this line and this line. And now I make coincident the arc with this point. That's all. Finished sketch. Now we have everything, all we need for applying sweep. This is the contour or profile, and this is the steering curve. I apply join, as I said. Okay, now there is another end. When we look through these holes, we see another end inside. Yes, look here. The problem is with this wall, because this must be a single room, not with a separation. So we'll create another sketch on this face. I wait a little to select what I want. This is what I want to create another sketch. F7. The sketch is simple. A line between these two, but this is not projected. Let me make this projection, which is better if I select another view. Line between these two ends and an arc from the midpoint or the center of this between these 2 points. Now I have this contour to use for cutting that wall, eliminating that wall. F6, finish sketch, extrude this to this face, but with cut. Yes. Now I unify the two rooms. They will have not this wall, which is now subtracted. Okay, you see, we have only one room now, as the drawing is. Next are the other two rooms, 1, 2, which have dimensions here, not complicated. We start from the plane XY. With the sketch, there are no separation or other walls. We draw the approximately shapes. And the last one is the unforgettable 7. Okay, finish sketch, extrude these two area to the same width like the other, 55 minus 6 multiplied by 2. Symmetrical. Cut. Okay. Now, as you can see, they are inside. Good. Now we create some orifices to look inside. One is this, diameter of 65, 15, radius 6, and other are this two in the bottom, centered of the arcs of 9. This face, 65 diameter, (15) after I place that to horizontal, which must be equal to be symmetrical. 15 split construction fillet 6 finish, extrude, cut, not that, this one, not the outside. 2 to the internal face, which is this. I wait here for a while. This. Okay. Now we can see what is inside. We go to the bottom, sketch, finish sketch, hole 9, to the face from inside, which is this. Yes. Okay. Now we can see more inside, even through these two holes. Yes. You see everything. Good. Next is this revolving interior hollow but we start with this thread, metric 64, with pitch 1.5, which is a thinner thread, on 16 with a flat end. Yes, then this chamfer 30 degrees with 2, and then the revolution. Let's do this. Hole, this face, this center, thread, ISO 64, which is a very large thread, 64, this. The normal pitch is 6, but we select a thinner one, 1.5. Distance is 16. And the end is flat, full depth, and now we see the preview. Okay, you can see everything here. Let's apply the chamfer, which is another kind, distance and angle. The face is this, from which we measure the angle. 2 millimeters is okay, and the angle is 30 on this edge. You see, it's okay. F6. Now we go inside this part, and knowing that we already made to here a hollow, and also to here another one, and also here the other one, we start by adding material inside this to create a volume like this, and another like this, upper this, above this, and below this. Yes, these are to be created because this is empty space. Dimensions are here. Let's do them. 1, 2, 3 rectangles. The plane is XY, F7, and we draw that rectangles. 1, 2, and 3. Okay, the height is measured from up. The height is measured from up, and this is 28 from here. 28. This is 5, and this is measured from the bottom with tolerance. 16 plus minus 0.2. So we know the procedure, dimension properties, symmetric 0.2. Okay, you know that you have to select this to see the tolerance. If you select this, you don't see the tolerance. You remember. Okay, now diameters. Let's project this line, which is on the center line, and then we convert to center line. Distance from here is 38, also with tolerance 38. Escape properties, tolerance is plus minus 0.027, symmetric 0.027. Okay, external is external is 48. The other one, it seems to be aligned with this, and there is no problem because we'll cut here. Yes, good. This diameter is 48. This is 52 with tolerance. Escape dimension properties plus minus 0.1, symmetric 0.1. Okay, internal is 37, dimension 37. Okay, all of them are okay, and we apply a cut here, which will be oh no, we have to place this at a certain dimension, so I disconnect it from up. You see, green up, delete, and now 33 here, very important. Good. We have to have material where to cut, yes, in the next moment. Finish sketch, revolve, one, two, three. The axis is known, and add, not cut, but add, and you will see here volumes, new volumes. Yes, this is important to be added. The rest we cut, but this are important. You see in the bottom also. I'll change the view without hidden lines, and you see everything now. Also inside this, yes, these are important elements. Good. And now let's create the hollow. Yes, we added some revolution volumes, and now we create this contour, all of it, to obtain the profile for revolving. The plane is XY, F7, and we draw a vertical line this one. We project the end lines, and then some other which are interesting for us. That's all. I make coincident the ends with ends. I apply a conventional distance here, say 25, which will be erased after, and then change this to a center line, and now we draw the contour. It starts from this level, so down, so I erase this dimension and I place the sketch inside. Select all and move here. This must be collinear with this, and then symmetry. and tangencies. The radius is 4 and this is equal to the other. Now we have a fully constrained contour, so finish, revolve, select the profile, select axis and cut. OK. Now we have everything finished about this revolution. The last feature to add is this combination of holes, diameter of 5 and 2.3 with this depth of 3. Let's create it. The distance is 40. We have to create a sketch here with a point at 40. Point somewhere in the air, and the same horizontal with this center point. The distance is 40. 40. Finish sketch, hole, simple, distance, angle, diameter of 5, depth of 3, plus on the same face and the same center a hole 2 to this face of tab 2.3 millimeters diameter. Okay, yes, this tiny hole is placed where it belongs. Assign material, steel cast, general aspect, steel cast, and some faces to be machined. These two are sure, and the other you will select, and this is very sure. The tolerated ones, which are these two and this, are very important. Okay, to be polished. The mass, the properties of this part are here, 5.777 kilograms. We can look now at the inside of this part to have a final image. You see, this is the chamber, the room, which is finished now, and then all the part. The other chamber is here. Yes, and as you can see, all of them are important. That's all. In conclusion, I want to tell you that I have made a considerable effort to model all 100 pieces in the collection which I have collected over the years. I beg you to try to model as many of them as possible in order to assert yourself in the field of 3D modeling and computer-aided design in general. I wish you good luck. I finish this for today. Thanks for watching. Bye bye.